Hello friends, I welcome you all in this session. As you are aware, in previous session we were discussing about hypothesis testing of two samples, and we have done several examples on hypothesis testing of means, hypothesis testing of proportions, and hypothesis testing of variance as well as standard deviation. In fact, we did solve a couple of examples on hypothesis testing of paired sample test, where the samples were dependent on each other. Now, let us take a situation where you want to compare means of 3 different groups, then what to do? Or let us say if there are 4 groups and you want to compare means. So, you can perform Z test or T test, but you will have to perform several such tests, and that would be quite an ineffective way of doing questions. So, there are some methods available which would be helpful in finding solution to problems where you have got 4 groups or 5 groups or 6 groups and so on, right. So, let us look at a new topic which is on analysis of variance and design of experiment. So, we will design certain experiments, and there are some methods like analysis of variance to analyze outcome of experiments of the design. So, experimental design is nothing but the plan or the setting or the structure of testing hypothesis, in which the researcher controls or manipulates or changes 1 or 2 variables. For example, let us say profit of an organization is a function of sales. So, if we let us say increase sales, how the profit will increase, or let us say in another example profit is a function of R&D investment. So, if we decrease R&D investment, how much profit will decrease. So, you will always have some dependent variables and some independent variables. So, whenever you make some changes in independent variable and see the effect of that change in dependent variable, that is known as experimentation, right. So, you can either control or manipulate independent variable, and you may have a situation, let us say, where there is a dependent variable and you have got more than one independent variables. So, you can in fact control or change more than one independent variable and see the effect of those changes on dependent variable. So, as I said, experiment contains dependent and independent variables. So, independent variable may be either treatment variable or classification variable. So, let us look at what is the meaning of treatment variable. In fact, treatment variable is a variable which an experimenter controls or modifies. Let us say the amount of bonuses offered to worker, then how the bonus would, let us say, improve his performance, improve productivity of the worker. So, that bonus is nothing but a kind of treatment, right. Let us say level of humidity in a workshop or in an assembly line, and we will see the effect of that humidity on performance of the worker, or the temperature performance on temperature, let us say temperature, how temperature is performing or affecting performance of a worker, right. So, these are examples of treatment variables. So, whenever we change something, that variable is called treatment variable, right. Classification variable is some characteristics of the experimental subject that was present prior to the experiment and is not a result of experimenter's manipulation or control. We will look at in detail what classification variable is. So, independent variables are also known as factors. Whenever we design any experiment, we can call independent variables as factors, right. So, let us look at couple of examples. So, let us say there is a very big retail chain of Big Bazaar. So, the executives of Big Bazaar, let us say, want to study the amount of sales which is taking place in different stores. So, let us say the executives have decided to have comparison of sales on these 4 stores, right. Let us say one of them is in the city, the other one is in suburb area, the third one is in a medium sized city, and fourth one is in a small town, right. So, there are 4 different stores of Big Bazaar, and the executives want to know how the sales figures are in these 4 stores, right. So, you can have one more example. Let us say the managers want to know how sales change over different weekdays. So, one can compare sales figures of a particular store on 5 days, right. Let us say Monday to Friday. So, in this study, let us say, so all these stores are nothing but independent variables, right. Or in this example, the weekdays are nothing but they are independent variables. Let us take one more example. A finance researcher might conduct a study to determine whether there is a significant difference in application fees for home loans. So, let us say there is a company, let's for example, let us take HDFC Bank, right. Now, it has got branches in 5 different areas, and customers can apply for loan in those 5 areas, right. So, the manager wants to know, is there any significant difference between, or is there any significant difference amongst fee which customers are paying in all those 5 areas, right. So, those 5 areas are nothing but kind of independent variable, right, and the fee would be the dependent variable. Okay. Let us take one more example. Suppose a manufacturing organization produces valves, and that has got different opening diameter. So, let us say the valve that is specified to have an opening of 6.37 centimeters. Quality controllers within the company might decide to test to determine how the openings for produced valves vary among 4 different machines on 3 different shifts. So, let us say there is a manufacturing organization which is producing valves, right, and those valves can be produced by 4 different machines and can be in different shifts, let us say morning shift and night shift, right. So, we want to know, is there any variation in the diameter of the valve if we look at all these machines and these 2 shifts, right. So, we will say that the 4 machines are nothing but they are independent variables, and the shifts are again independent variables, right. So, whether an independent variable can be manipulated by the researcher depends on the concept being studied. Independent variables such as shift, or let us say number of machines, or geographical areas, or let us say the 4 stores of Big Bazaars, all these are nothing but these are called classification variables, right. So, each independent variable can have 2 or more classification variables, right. So, and these variables can be either categorical or numerical, right. So, let us say gender is one of the independent variable, right. So, we can have male and females, right. These 2 are two levels of gender, or let us say male, female and transgender. So, for gender independent variable there are 3 levels, right. So, these are levels are nothing but different subcategories, right, of independent variable which we use in experimental design. So far we talked about independent variable. Let us talk about dependent variable. Dependent variable is nothing but the response. As I said, if we are testing, let us say whether the application fee of loan is different in 3 different villages. So, that application fee is nothing but dependent variable, that is response to some independent variable. It is the measurement taken under the conditions of experimental design that reflects the effect of the independent variable. So, let us take once again the same example. So, you have got let us say profit is nothing but response variable or dependent variable, and let us say R&D investment is independent variable or also known as factor, right. So, in big bazaar example we will say that dependent variable is nothing but sales volume, right. We can have let us say one more example over here. So, let us say in a store of big bazaar or for any other store for that matter, let us say customers are paying their bills either through cash or through debit card or through credit card or through some other means. So, we can compare is there any significant difference amongst those modes of payments so far as sales in that particular store is concerned. So, in loan application example, the application fee is nothing but the response variable or dependent variable. In valve experiment example, the opening, the size of the valve is nothing but dependent variable. So, experimental designs discussed here can be analyzed statistically by a group of techniques, and so this group of techniques is referred as analysis of variance, right. So, what is analysis of variance? ANOVA in other words is how we are analyzing the outputs of different experiments, and we use certain statistical techniques, and those techniques are called ANOVA, analysis of variance. Let us look at this example. So, you can have different examples, and this is one example I have taken over here. So, let us say we will take the valve opening example. So, let us say there is something valve which has got a diameter like this, right. So, valves are being manufactured on 4 different machines, right, and let us say we have manufactured 24 valves, and these are the diameters of these 24 valves. So, let us say 6.26, 6.25 and so on, right, and the diameter of this valve is 6.34, right. So, there are 24 valves. Okay. When you take the mean of all these valves, it becomes 6.34. Now, if you look at that, there is only one valve which has got mean equal to 6.34. It has happened just by chance. It is not necessary that you will have valves whose diameter is mean of all the valves, right. It is not necessary. So, for this example, this is the mean, and the sum of squared deviation SST, sum of squared deviation is 0.390. Actually, this sum of squared deviation should have been 0. Why this is not 0? That is the question. Okay. So, sum of squared deviation, it is nothing but xi minus x bar whole square summation of that, right. So, we know that xi is this, right. So, let us say this is xi minus 6.34 whole square plus this minus 6.34 whole square plus so on, right. You just keep on adding all this. So, that sum would be nothing but it would be 0.39 or approximately 0.40, right. So, why this sum of squared deviation is not 0, that is the question. So, as I said, there is only one valve whose diameter is 6.34 centimeter. So, why in fact you can have multiple reasons why these diameters are not same when we produce these diameters, when we produce these valves. So, there can be again multiple reasons why these diameters are not same. This could be due to, let us say, different workers working on a machine, let us say different in different shifts they are working, they are getting, let us say, raw material from different vendors. So, there can be multiple reasons, either it says due to operator or supplier or production conditions and humidity and temperature and so on, right. So, these are different reasons why we are making or why valves of different diameters are being produced. So, this is not 0, why this SST sum of square of deviation is not 0, right. So, we will try to find out answers, we will try to find out why reasons why this is not 0, right. So, using various types of experimental designs, we can explore some possible reasons for this variance with analysis of variance techniques. Okay. So, there are many different types of experimental designs are possible, and there are basically 3 types of experimental designs available. The first one is completely randomized design, completely randomized, second is randomized block, and third is factorial experiment. So, let us look at what is completely randomized design. So, the completely randomized design, and we will use one way ANOVA to find out the outcome of design of experiment. So, this is one of the designs, right, completely randomized design. So, we assign, in fact, this is the simplest amongst all, as I said. So, in the completely randomized design, subjects are assigned randomly to treatments. So, that is why it is called completely randomized design. So, the completely randomized design contains one independent variable with 2 or more levels, right, or classification. So, let us look at this example. So, we will take the same valve manufacturing example. So, let us say these valves are being manufactured on 4 different machines, right. So, machine 1 is producing these valves, machine 2 these valves, machine 3 these valves, and machine 4 these valves, right. So, independent variable is you have got let us say there are 4 operators, not 4 machines. So, machine operators is an independent variable, there are 4 different operators, and the classification level is, let us say 1, 2, 3, 4 or A, B, C, D, right. So, the question is there any significant difference amongst means of all these valves produced by these 4 operators. So, that is the question, is there a significant difference in the mean value of diameter of these 24 valves produced by 4 operators. So, this is an example, right, of independent variable, and what would be the dependent variable by the way. So, independent variables are 4 different operators, right. Dependent variable is nothing but these diameters, right. Okay. So, let us look at one more slide. So, what would be the dependent variable in case of big bazaar? So, the in fact the demographical variables, that 4 different stores, let us say in urban, suburban, inside city and all those. So, those 4 are independent variables, and the levels are the treatments are those 4 cities, right. Okay. So, and the dependent variable is sales in terms of rupees, or let us say in terms of quantity, whatever it is. Okay. So, this how you should know the difference between dependent variable and independent variable. So, you will always have some subcategories of independent variables, and those subcategories are called either level or classification variables. Let us look at what is one way analysis of variance or one way ANOVA. So, if you look at the machine operator example, so we can find out the difference between let us say difference in means of these 4 workers using t test, because there are, if you look at this, there are 4 workers, right. So, we can perform t test between first and second, then first and third, first and fourth. So, how many t tests we would be performing? 3, right. Then second and third, second and fourth, 5, and then second and fourth, 6. So, to get the answer of this question, we will have to perform 6 t tests, right. In fact, these 4 samples would be requiring, it is 4C2, 6 individual t tests to accomplish the analysis of these 2 groups. So, either you use t test 6 times to solve this question, or you use a technique called one way ANOVA, which in one stage itself will give the difference amongst 4 means, right. We also know that when alpha is equal to 0.5. So, there is only just 5% chance of rejecting null hypothesis when it is true, right. So, if you let us say perform 6 tests, right, then the probability of error would increase, right, is not it. So, if enough tests are performed, eventually one or more null hypothesis will falsely rejected by chance, right. So, if this is valid, then with 6 tests the error rate compounds. So, there is a possibility of having more and more error, right. Let me put it in this way. So, probability of not making type 1 error is 0.95, right. When I say alpha is equal to 0.05, probability of not making type 1 error is 0.5. So, when you run t test 6 times, so this would be the probability of probability of not making type 1 error. So, 1 minus this is the probability of making type 1 error, which is very high, is not it. So, that value 1 minus 0.9 to the power 6, right, is the probability of making error, right, or probability of making type 1 error. So, which is much greater than 0.05, right. So, a technique has been developed that analyzes all sample means at one time and thus precludes build up of error rate. So, you can minimize the errors which you build over performing 6 hypothesis testing, right. So, that is why ANOVA is used. A completely randomized design is analyzed by one way ANOVA, and what is this? So, initially in this one way ANOVA what we do, if there are let us say k samples. So, you can have the following hypothesis as null hypothesis and alternative hypothesis. So, we will say that all means are equal, right. So, there is no significant difference amongst these means. So, mu 1 is equal to mu 2 equal to mu k, right. So, this is our null hypothesis, and alternative hypothesis, at least one of the means is different from the other mean. So, let us say there are 6 means. If mu 1 and mu 2 are not equal, then alternative hypothesis would apply. So, this is null hypothesis and alternative hypothesis. The null hypothesis states that the population means for all treatment levels are equal. So, all hypothesis means are same, right. Because of the way alternative hypothesis is stated, even if one of the population is mean is different from others, will reject the null hypothesis. So, there is a possibility that mu 3 and mu 2 are not equal, then will reject the null hypothesis, right. So, a completely randomized design is analyzed by one way ANOVA. So, testing these hypotheses by using one way ANOVA is accomplished by partitioning the total variance of the data into the following two variances. So, we have said in the beginning in one of the slide that the sum of total variance was not 0 in the valve opening example. So, what was the reason for that? So, what we did, we in fact divided the total variance into two different variances. It is called error variance and explained variance, right, or variance resulting from the independent variable or from the treatment, and error variance are that portion of the total variance which is unexplained. So, total variance is explained variance plus unexplained variance, is not it. So, we can evaluate difference among means of two or more groups. So, you can have different example, let us say the number of accidents taking place in 3 different shifts. So, we can compare in which shift the accidents are more. So, the null hypothesis can be framed like this. Let us say the number of accidents are same in all these 3 shifts, mu 1, mu 2, mu 3 are same, and alternative would be they are not same, is not it. Let us look at this expected mileage of 5 brands of tires. So, you have got let us say A, B, C, D and E, these are 5 brands of tires. So, when you measure the mileage of brand A tires, you will get some mileage, let us say M A, similarly M B and C, D, E, right, M E. So, you are comparing all these 5 means. So, again null hypothesis would be mu 1 to mu 5 all are mu 1 to mu 5 all are same and not equal to is alternative hypothesis. So, whenever we go for hypothesis testing using one way ANOVA, there are certain assumptions which are to be kept in mind. So, we always say that the populations are normally distributed and the populations have equal variances, samples are randomly and independently drawn. So, if these conditions are, if these assumptions are fulfilled, then only we apply one way ANOVA. We have already talked about this. So, this is our null hypothesis, C is nothing but number of groups, right. So, mu 1 to mu 3 and so on up to mu C all are same, right, all population means are equal. And alternative hypothesis, not all of the population means are same, right. So, at least one population mean has to be different to reject null hypothesis, right. So, before I start this slide, let me summarize what we have done in today's session. In today's session, we have discussed in detail what is design of experiment, what is independent variable, what is the meaning of treatment variable, what is the meaning of classification variable, what is the meaning of dependent variable. Then we have seen different examples of dependent and independent variables, and when we compare means of more than two groups, then we use analysis of variance, not t-test. The reason is that when we have let us say 3 groups, then we will have to perform t-test more than one time. So, let us say you will have to perform t-test in case of 3 groups, you will be having first, second, first and third, second and third, right. So, 3 tests you will have to perform, and when we do this, there is a possibility of having more and more error, right. There is a probability of rejecting null hypothesis, it would be let us say 1 minus 0.95 to the power 3, that would be the probability, right. So, with this let me stop here. In next class we will discuss some more points related to analysis of variance. Thank you.